Hello my dear stars, welcome back to the session. Trigonometric ratios of some specific angles. Let's take an equilateral triangle ABC with side 2A. Here AD is perpendicular on BC. So we can say, in other words, AD is perpendicular bisector of BC and AD also bisects angle A. Since angle A is 60 degrees, it is an equilateral triangle. Each angle is 60 degrees, right? So AC bisects angle A, so which is of 30 degrees, right? So each side is 2A, and since AD is perpendicular bisector, then BD is equal to DC. Then this is A, this is A. We know together this is 2A. So into two equal parts, so A and A. Now here we have got two right angle triangles. One is ABD, another one is ACD. So in this right angle triangle, by using Pythagoras theorem, so we have this side, we have hypotenuse, so we can find this side. That is by using Pythagoras theorem, hypotenuse square equal to side square plus side square. So from this, side square equal to hypotenuse square minus side square. Okay, so then we have got square root 3a. Here AD we have got square root 3a. So in this right angle triangle we have all sides. Now trigonometric ratios for angles are 60 degrees. Let's determine. In right angle triangle ADB, so we have sine 60 degrees. According to sine definition, that is opposite side to theta over hypotenuse. So we can also say perpendicular over hypotenuse h. So sine 60 degrees equal to P by h. Here opposite side to theta, that is perpendicular AD and hypotenuse AB. So AD over AB, here AD is square root 3a and AB is 2a. So square root 3a over 2a. Here a gets cancelled, then whose value square root 3 over 2. So similarly cos 60 degrees, and cos definition, adjacent side to theta over hypotenuse, or we can say base over hypotenuse, B by h. So then BD by AB, here BD is A and AB is 2A. So A over 2A, here A divides one time, so 1 over 2. So cos 60 degrees value 1 over 2. Tan 60 degrees. So tan definition, perpendicular over base, that is P by B, or we can say opposite side to theta over adjacent side to theta. So AD over BD, here AD is square root 3a and BD is A. So here A divides A one time, so whose value square root 3. And next cosecant 60 degrees. And we know cosecant and sine reciprocal to each other. That we have already discussed in the previous session, right? So 1 over sine 60 degrees. Cosecant 60 degrees equal to 1 over sine 60 degrees. So we can reverse it, reciprocalize. So whose value 2 over square root 3. And secant 60 degrees. Again we know secant and cos, these two are reciprocal to each other. So secant 60 degrees is equal to 1 over cos 60 degrees. So here cos 60 degrees value 1 over 2. So reverse it, reciprocalize. So 2 over 1, that is 2. So secant 60 degrees value 2. And finally cot 60 degrees. Again cot and tan reciprocal to each other. So cot 60 degrees is equal to 1 over tan 60 degrees. So on reciprocalizing this, 1 over square root 3. Because square root 3 we can write as square root 3 over 1. So on reverse it, 1 over square root 3. So these are the values of trigonometric ratios for angle 60 degrees. Right? Now let's derive trigonometric ratios for angles of 30 degrees. So again in right angle triangle ADB, so we have sine 30 degrees. So now here theta is here. So sine 30 degrees is equal to, again, opposite side to theta over hypotenuse, or we can say perpendicular over h. So here BD over AB, BD is A and AB is 2A. So here A divides A one time, so which is equal to 1 over 2, that is half. So sine 30 degrees equal to half. And cos 30 degrees, according to cos definition, adjacent side to theta over hypotenuse, that is square root 3a over 2a. Here a divides a one time, so whose value square root 3 over 2. And tan 30 degrees, that is opposite side to theta over adjacent side to theta, or we can say perpendicular over base, BD over AD. So that is a over square root 3a. Here a divides a one time, so whose value 1 over square root 3. And rest all we can find easily. Cosecant 30 degrees. Cosecant and sine are reciprocal to each other, just reverse it. So 2 over 1, which is 2. And secant 30 degrees. Secant and cos reciprocal to each other, just reverse it. 2 over square root 3. And cot 30 degrees equal to cot and tan reciprocal to each other, just reverse tan 30 value, that is square root 3. So these are values of trigonometric ratios for angles of 30 degrees. Now let's derive trigonometric ratios for angles of 45 degrees. Since it is 90 degrees, this is 45 degrees, so this is also 45 degrees. Then it is an isosceles right angle triangle. So these two sides are equal. So let's take each side is AA. So by using Pythagoras theorem, so we can find hypotenuse, that is square root 2a. So we have got all sides. Now in right angle triangle ABC, we have sine 45 degrees. So according to sine definition, that is opposite side to theta over hypotenuse, or we can say perpendicular over hypotenuse, P by H. So here perpendicular is BC and hypotenuse is AC. So BC over AC, BC is A and AC is square root 2a. Here a divides a one time, so which is equal to 1 over square root 2. And cos 45 degrees. According to cos definition, that is base over hypotenuse, AB over AC. So that is a over square root 2a, again a divides a one time, so which is equal to 1 over square root 2. And tan 45 degrees, that is opposite side to theta over adjacent side to theta, or we can say perpendicular over base, a by a divides a one time, so tan 45 degrees equal to 1. And rest all we can find easily. Cosecant and sine reciprocal to each other, so cosecant 45 degrees equal to, reverse it, square root 2 over 1, which is square root 2. Secant 45 degrees. Secant and cos, these two are reciprocal to each other, just reverse it, square root 2 over 1, square root 2. Cot 45 degrees. Cot and tan reciprocal to each other, just reverse it, 1 over 1, 1 only. So cot 45 degrees is equal to 1. So these are the values of trigonometric ratios for angles of 45 degrees. Now let's derive trigonometric ratios for angle of 0 degrees. Very tricky, please concentrate. So here is the diagram. So triangle ABC, right angle at B. Okay. In triangle ABC, as angle A gets smaller and smaller, the length of the side BC decreases and the point C gets closer to point B. Here you can see, in triangle ABC, as angle A gets smaller and smaller, initially angle A is this much, then this much, then this much, then almost 0. Okay. The length of the side BC decreases. Initially BC length is this much, then this much. When angle decreases, BC length is this much. Angle decreases, BC length is this much. When angle almost 0, so it coincides with B. Okay. So decreases, the point C gets closer to point B. Right. Finally, when angle A becomes very close to 0, when angle A becomes 0 or very close to 0, then AC becomes almost the same as AB. AC length almost same as AB length, right? Initially this is AC length, this is AC length, this is AC length. When angle A almost 0, then AC length almost equal to AB, right? And BC gets very close to 0. Here there is no gap, BC gets almost 0, right? So the value of sin A is equal to BC by AC, we know that. Sin A equal to opposite side to theta over hypotenuse, right? So BC by AC is very close to 0 because here BC is almost 0. 0 by anything is 0, right? So the value of sin A is equal to BC by AC is very close to 0. Also, when angle is very close to 0 degrees, when the angle is very close to 0 degrees, AC is nearly the same as AB, and so the value of cos A is equal to AB by AC. We know that adjacent side over hypotenuse, right? So here adjacent side is AB and AC also same, right? So whose value closer to 1? Got it? AB is equal to AC. When angle is 0, then AB becomes AC, and adjacent side and hypotenuse both are same, and whose ratio is almost equal to 1. Got it? So when angle A equal to 0, sin 0 equal to 0 and cos 0 equal to 1. So using this, we have tan 0 equal to, again by using quotient relation, that is tan theta is equal to sin theta by cos theta. So tan 0 equal to sin 0 by cos 0. So 0 by 1, whose value 0. So tan 0 value 0. And cot 0 value, cot is reciprocal to tan, right? So 1 by tan 0, that is 1 by 0. And we know division with 0 is not defined, so which is not defined, and this is represented by this symbol infinity. Okay, so cot 0 value not defined, and whose value infinity. Secant 0 degrees, and we know secant and cos reciprocal to each other. So secant 0 equal to 1 by cos 0, cos 0 value 1, so 1 by 1, whose value 1. And finally cosecant 0, that is cosecant and sine reciprocal to each other. So cosecant 0 equal to 1 by sin 0 degrees, and sin 0 value 0. Again division with 0 is not possible, so which is not defined, so we can represent with infinity. So these are the trigonometric ratios for angles of 0 degrees. What are they? Sin 0 degrees 0, cos 0 degrees 1, tan 0 degrees 0, cot 0 degrees infinity, or we can say not defined, and secant 0 degrees 1 and cosecant 0 degrees not defined or infinity. Correct? Next, trigonometric ratios for angle 90 degrees. This is also tricky, concentrate. So in right angle triangle ABC, right angled at B. In triangle ABC, as angle A gets larger and larger, angle C gets smaller and smaller, and the length of the side AB goes on decreasing. That is, point A gets closer to point B. Here you can see, in triangle ABC, as angle A gets larger and larger. So initially this is angle A, this much, okay. Now increased more, now almost 90 degrees. So when it is keep on increasing, initially angle C is this much, angle C decreased more, and angle C almost 0, right? And the length of the side AB goes on decreasing. Initially this is the length, AB length, you can see decreased, you can see decreased more, almost coincide with what? B, 0. That is, point A gets closer to point B. Finally, when angle A is very close to 90 degrees, here you can say angle A very close to 90 degrees, angle C becomes very close to 0. Angle C almost 0, okay, and the side AC almost coincides with side BC. Here you can see AB almost coincides with side BC, okay. So which means AB length is equal to BC length, right? So sin A is equal to BC over AC, that is opposite side to theta over hypotenuse. So here whose value closer to 1, because BC and AB, when it becomes 90 degrees, BC and AB same. So BC and AC same, so whose ratio 1. Got it? Also, when side AC is nearly the same as side BC, angle A is very close to 90 degrees and the side AB is nearly 0. Side AB is what? Nearly 0. So cos A value closer to 0. Because cos theta equal to adjacent side to theta or base over hypotenuse. Here base is almost 0 and hypotenuse is equal to BC. So 0 over anything is 0. So cos A value almost 0. So from this broadly we can understand, as AB becomes BC and angle A becomes 90 degrees, almost angle C becomes 0 degrees. So from this, sin A is equal to BC by AC. By definition, opposite side over hypotenuse. Here opposite side and hypotenuse both are equal, then whose ratio 1. And cos A value closer to 0 because cos definition base over hypotenuse. Here base almost 0, 0 over hypotenuse. Here hypotenuse is BC, so 0 by BC is 0, right? So we can derive remaining trigonometric ratios by using these two. So when angle A equal to 90 degrees, sin 90 degrees equal to 1 and cos 90 degrees equal to 0. So we have already discussed here. So using these we have tan 90 degrees equal to tan theta equal to sin theta by cos theta. So sin 90 by cos 90, sin 90 is 1, cos 90 is 0, 1 by 0, and we know division with 0 is not possible, not defined. So tan 90 degrees value not defined, or we can say infinity, right? Cot 90 degrees, we know cot and tan are reciprocal to each other. So on reversing, 0 by 1, right? That is 0. So cot 90 degrees value 0. And secant 90 degrees, and we know secant and cos are reciprocal to each other, that is 1 over cos 90 degrees. Cos 90 degrees value 0, so 1 over 0. So division with 0 is not defined, so which is not defined. So we can say secant 90 degrees value infinity, not defined. And finally cosecant 90 degrees, and we know cosecant and sine reciprocal to each other. So cosecant 90 degrees equal to 1 over sin 90 degrees. Sin 90 degrees value 1, so 1 over 1 whose value 1. So these are the trigonometric ratios for angle 90 degrees. Clear? So let's summarize all together. Values of trigonometric ratios for some specific angles: sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. We have already derived 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. This entire table we can remember very easily. How it is? Simple. Sin 0, 0, sin 30, 1 over 2, sin 45. Just remember this row. Even this row also you no need to remember. For that also there is a trick. So put sin 0 value square root 0 by 4. Sin 30 value square root 1 by 4. Sin 45 value square root 2 by 4. Sin 60 value square root 3 by 4. And sin 90 value square root 4 by 4. Square root 0 by 4 is 0. Square root 0, 0. Square root 1 over 4. Square root 1 is 1, square root 4 is 2. That is 1 by 2. Square root 45 degrees. That is square root 2 by 4. 2 divides 4 2 times. Square root 1 is 1 and square root 2 is square root 2 only. And sin 60 degrees. That is square root 3 by 4. Square root 3 is 3 and square root 4 is 2. Sin 90 value square root 4 over 4. 4 divides 4 1 times. Square root 1 is 1. And for cos, just write these all values in reverse order. Sin 0 value sin 90 1, then this, then this, then this, then this. You can look at. And tan values sin by cos, divide these two. 0 by 1 0, this by this, 2 gets cancelled, 1 by square root 3. Here this divides this one time. Here 2 gets cancelled, square root 3, 1 by 0, undefined. Cosecant theta, we know cosecant and sine reciprocal to each other. Just reverse it. 0 by 1, infinity. Reverse it, 2, 2 by 1, 2. Reverse it, square root 2 by 1, square root 2. Reverse it, 2 by square root 3. Reverse it, 1. And secant theta, secant and cos reciprocal to each other. Reverse it, 1 by 1, 1. Reverse it, 2 by square root 3. Reverse it, square root 2. Reverse it, 2. Reverse it, 1 by 0, infinity. And finally cot, you can divide these two or you can reciprocal tan. Either way you get. So if you divide these two, infinity by 1, infinity, this by this, that is square root 3, this by this 1, this by this 1 by square root 3, this by this 0. Got it? So this way you can remember easily these all values. And finally there are some very important note points. They are: the value of sin theta increases from 0 to 1 and cos theta decreases from 1 to 0. you have already seen in the table, right? Where 0 is lesser than or equal to theta is lesser than or equal to 90 degrees. Next, division by 0 is not allowed, hence 1 by 0 is an indeterminate or not defined value. In the case of tan theta, the values increases from 0 to infinity, where 0 is lesser than or equal to theta is lesser than or equal to 90 degrees. In the case of cot theta, the values decreases from infinity to 0. The same we have already seen, where 0 is lesser than or equal to theta is lesser than or equal to 90 degrees. In the case of cosecant theta, the values decreases from infinity to 1, where 0 is lesser than or equal to theta is lesser than or equal to 90 degrees. And finally, in the case of secant theta, the values increases from 1 to infinity, where 0 is lesser than or equal to theta is lesser than 90 degrees. So briefly we can say sin theta values increases from 0 to 1 and cos theta values decreases from 1 to 0. And division with 0 is not defined. And tan theta values increases from 0 to infinity and cot theta values decreases from infinity to 0, and cosecant theta values decreases from infinity to 1 and secant theta values increases from 1 to infinity, right? So these are the things which you need to remember. So by using all these information, let's solve some example problems.